Welcome, everyone. My name is Julian Arni. I work as a Haskell consultant for Turing Jump. And I'm going to talk about testing with Servant. But first, I have a question. What image comes to mind when you think of testing without quick check? Does anyone have an image that they think of? Yeah.
Testing without quick check.
Without quick check, yeah. Yeah. Okay. You had something? Sadness, okay. Anyone else?
Unit tests.
Unit tests, yeah. Yeah, this is what I think of. So, I think I'm being punished. I don't know what I've done wrong, but I feel like I'm being punished by having to do something very repetitive, right? I have to mention all the points at which something's happening. And even then, I of course don't cover nearly enough to be fairly certain that I got it right. Whereas in reality, what I would like to feel when I'm testing is as if I was Zen master that figured out the turning word and suddenly brought my computer to enlightenment. Or like, if I'm allowed the blasphemy this early in the talk, like God at the beginning of time, but I'll say instead, let there be tests, and I'll see that they're good, right? I want to feel like I'm incredibly powerful and succinct in my expressions, and test a wide variety of things. And quick check helps. It helps a lot, considerably. And in particular with this problem over here, it helps. But what I want to show is that we can go much further in this succinctness and the expressivity of our tests by taking a couple of steps. And what are those steps? Well, the first step is better abstractions. I don't think anyone's going to complain about that. But more specifically, what I mean is we should, so take a step back. I'll be talking about tests in the context of a web application. Now, it doesn't really matter what your web application does. It doesn't really matter whether it was written with the Servant Web Framework, although if it was, all the better. In fact, to some extent, it doesn't even matter whether it was written in Haskell. But in the context of web applications, the better abstraction that I'm thinking of is the ability to talk about your API, to state things about your API. And we'll get to that in a second. The other step is embedding domain-specific knowledge in your tests. We tend to think that all our applications are special snowflakes, but the reality is that there are a lot of things that everyone has to do or should do, right? So if you think about what a web application is, if you just look at the HTTP protocol, there's this huge degree of similarity between the actual, from a high-level perspective, the behavioral similarity between your application and someone else's. It handles HTTP requests that are formatted in a specific way, and it responds in a specific way. But even above that, there are tons of things that you're supposed to be aware of. Lots of little details that you're supposed to be aware of, such as, I don't know, like best practices in HTML, right? When your HTML is supposed to have a doc type. Your JSON is supposed to have best practices as well. Don't return top-level JSON. There are lots of things that every web application should do in order to be a good denizen of the universe of web applications, of the internet, I guess. So if we can encode all of these things, then we can in libraries, then you no longer have to think about them yourself. So those are the two steps. Now, on the topic of better abstractions, I mentioned that crucially, we're going to want to be able to state things about our application's API. By the way, if anyone has a question, just raise your hand, and if it's a crucial moment, I might ignore you. But if not, I'll get to you. Does anyone have a question? Okay. So better abstractions. What do I mean by this? So I mean specifically a language for talking about APIs, describing APIs. This is what servant is. Who here is familiar with servant? Cool. Well, for those of you who are not, I'm going to give a very short introduction. It will it'll take a few minutes. The essence of the idea is that there's a domain-specific language that you can use to describe web applications. So you might have heard that servant is a web framework. This is not wrong. It's also a web framework. But there's something that it's missing. There's something, in a sense, it's a simplification. Servant is more than that. In reality, it's, as I said, a domain-specific language where the expressions of that language are APIs, the description of an API. And importantly, crucially, we can interpret these expressions in particular ways. So let's first see what the DSL looks like. So at the top level, we have an API, and an API may be a verb, or the combination. The symbol over here is called it's called either alternative or fish. Zonka came up with the name fish, and I quite like it. And this he calls bird face. So this combines. So if I have an API and another API, I can describe an API that's the combination of both these APIs, right? So if I have my users server and I have my my cat server, and each one has a certain number of endpoints, there's also a possible server that is the combination of both of those. Then I can also modify. So for instance, if I have an API, I can say, I can talk about the API that's exactly like that API, but everything has a URL prefix, such as, version 1. Right? So if I have an API and I suddenly decide to version it, I can add version 1 as a prefix to all the URLs in that API. And that's another API. The verb over there is one of the usual HTTP verbs, get, delete, put, post, with a C type, which we'll get to in a second, and a Haskell type. This type over here describes what the response that the server will give is. So get ... bool means that the server at that endpoint, if a request is made that reaches that endpoint, will respond with a Boolean. Similarly for ints or strings or whatever else. So the modifier can be a path literal, like the v1 example that I mentioned just a second ago, or a request body combinator. For instance, I can say, this API, all of the elements of this API, expect the requests to have a body of a particular type. So for instance, I might expect at a particular location that someone sends a request with a user serialized as JSON, say, in the body. And then a capture is a URL capture, and there are more. All of these are extensible. They're more already in the packages, and you can add your own. And then C-type is just a content type, JSON, HTML. If you don't know if you're not familiar, if web programming is not your thing, it doesn't really matter what those are. But importantly, they're different I'll just say it. They're different representations of the same data, right? So I can either, for instance, serialize something by using the show instance or the toJSON instance. And in web programming, we call this the content type in a way. Any questions so far about this language? Okay. So crucially, as I said, so let's take a look at an example. This is a relatively small example. So let's start from here. So there's one thing here inside on the right-hand side of the bird face. Let's ignore that for now. User, which is, I forgot to mention this. All this is happening at the type level. So the domain, the DSL exists at the type level. So your API descriptions are types. I'm not going to get into why, because it's not really a talk about servant, but that's how it is. So this is a symbol, a type level symbol. Are people familiar with that? Okay. So I'm saying there's an API that starts with user. So everything that's going on here is in a URL that starts with user /. And then let's see here there are two sub APIs, two endpoints. It turns out combined with the fish. And on the left-hand side, I have a get JSON user. That's to say, I accept GET requests and serialize things with a content type JSON. And the thing that I serialize is a user. And this is a data type in my normal Haskell world. And then here, I have a post. So I accept post requests. And I also respond with a user, but I require that the request have in its body a username, serialized as JSON. Is that relatively clear? Okay. So, in essence, two endpoints. Another way. So there are two endpoints, both of the URL user. One's a get, the other's a post. Right? This is what this is saying about that API. Now, I can interpret this in a variety of ways. I can generate documentation for this, right? So just like when you imagine a language, there's an interpreter for that language, and generally there's just one interpreter. Whereas here there are quite a number of them, and they're all interesting, used in different ways. So you could interpret this as a way of describing client functions. So you could generate client functions in Haskell for this, or you can generate documentation for this API, or you can, with the help of handlers, generate an application. So there are multiple interpretations of this DSL. Yeah. So in essence, I have all these I have these combinators that when I put them together, I get something that is an expression in the servant DSL. And now I can talk about these things. I can talk about, I can assert things about about APIs. Now, what's an example? Well, so let's start by taking a step back. This is a function from the package swagger2, which Nikolai wrote. I don't think Nikolai's in the room, but he's somewhere in the conference. What does it do? Well, it has this toSchema function, class, which gives a JSON schema, which, if you're familiar with XML schema, is sort of like that, but for JSON. It specifies what your JSON looks like. It says, oh, this field has an integer, and it's never more than 200, and it's always positive, say. And it has another field, and it's named something else, and so on. So there's a class for this that comes, again, from the swagger2 package. But importantly, so this is very useful if you're writing fairly professional web applications. This is often very useful to your users and also as documentation for your company itself, or internal documentation, because it's sort of a standardized way where people can figure out what it is that they should be expecting from your web application as responses, as well as what they should be trying to send, right? So it's great documentation. It's useful to validate input and output. Usually, it's a big boon to everyone involved if you have these schemata. But it's important that it matches the actual implementation of 2JSON for your API, right? It's important that it's correct. It's worse than not having a schema if you have a schema that's incorrect. It drives people up walls. So what do we do? Well, Nikolai was kind enough to provide a function that checks whether for any type, for any value that's an instance of the appropriate classes, when I try to serialize it as JSON, the JSON value that I get matches the schema. And if not, then I get a validation error. Right? So this checks that the property that I want to hold works. And if you're using your generic, both of these have generic instances. If you're using generic instances, you're okay. But often, almost invariably, as time progresses, you want to change the name of a field somewhere, and so you write manual instances. But then you have to make sure that when you write manual instances, you're doing both of them at the same time. That goes wrong unless you have this in a test. But this is great. But all of you in the room now know about this. But perhaps the people, your coworkers, don't yet. And so you go to work on Monday, and you create a new type, and you add a test for this. You make sure you generate arbitrary values, and you make sure that this property holds, that the schema, that the schema is correct. That the schema does in fact describe what JSON is generated. But then your later self, or a coworker, doesn't know about this because she wasn't here in the conference room. And in fact, it's unfair to expect everyone to know everything. There are a lot of these things to keep in mind. So, the next time after that someone writes a new type, there is no test for it. There's no test for this. And there's no meta test saying, look, every time a new type comes up, make sure that there's a test for that test of this property. All right, so we're sort of in a bind here. And moreover, this is a typical sort of situation where you have to do things repetitively, right? For every type, I want this property to hold. For every type in my application, I want this property to hold. And the current way of doing that, insofar as anyone does it, is to manually, for every type, write this test. And it's no wonder that people don't reach this level of professionalism of having these tests extensively, because it's a bore. It's a lot of code. It's a lot of things to remember, to do, in order to reach that place. But there is an easier way, which is this. This is also this is from the Servant Swagger package. And I think Nikolai and David Johnson wrote this. I don't know which one of them, both of them wrote that package. I don't know which one wrote this function. But let's try to see, it's kind of a mouthful, but let's try to see what's going on. So the important argument, as you might have noticed from the highlighting, is this proxy API. As I mentioned, your API descriptions are types. So the way to pass them as arguments to functions, since you don't have a value, is to pass a proxy that represents that type. And then the return type is a spec, which is a test in the HSpec world, one of the testing frameworks. And judging by the name of the test, it does exactly what we want it to do. It validates every toJSON. So let's assume that that's correct. So that means that presumably it's getting the types, a lot of types from the API, and running tests for all of them. And indeed, if we look at this, the constraint, this is looking at all the body types. So all of the response. Remember how we had get JSON user. So the user over there is the body is what they call the body type because it's in the response body. So it's a little bit of type level programming that goes through all of your API, looks at all of your verbs, which is to say, and all of your body types, which is to say, all of the things that all of the types with which your application responds, picks those that could possibly be JSON, that you state that could possibly be JSON, and of those, it asserts that they should be every, that is to say, all of, they should have instances for all of these classes. So that's the constraint. So it's saying that in my API, we only had one body type. I had two endpoints, I had get and post, but they both returned user. So it's saying user should be typeable, show, arbitrary, to JSON, and to schema. If I had another type, if I was also returning cat, then it would say, the constraint would say, user and cat should be all of those classes. Now we can tell why toJSON and toSchema are required, because I'm going to run this function, right, on them. I'm going to run this function on all of those types. So we know why we need those two, because we need it here. And then we need arbitrary in order to generate arbitrary values of that type. We need show so that we can show when a test fails, we can show it. And typeable in order to name the tests. So we name the tests according to their type. So this is the sort of divine expressiveness that I really would like my tests to have, right? So this is one function that is saying any type that my web application ever returns, now or in the future, should satisfy this property. And all I have to do is pass one argument and I'm done. Yeah. So and the crucial point here was this argument, right? The ability to pass the API as an argument, to assert things of it. Yep.
So body type type family, which applies to API, and schema is something that kind of accumulates the constraint over all the types, which are as a result of body types.
Yeah, so I actually never looked at the implementation of tmap. I imagine it actually is itself a type function because there's every and then there's presumably something else besides every. So in this case it's stating that all of these constraints should be true of the list of types that this returns, right? But I imagine that there might be any as well instead of every. Although I can't actually imagine a use case for any. Well, anyhow.
How could you implement any anyway?
Yeah, true. You can't backtrack, right? True. Then I don't know. I think I can't imagine anything else besides every being useful here. Right. So there's another example from a different package, and this is similar in spirit. What it does is it checks that your toJSON and your from JSON instances for all types in your API are inverses, right? So if I have any value, that is a toJSON instance, and I convert it to JSON, and then I convert it back, I get the original value. So QuickCheck gave us this amazing property where instead of doing unit tests, right, instead of saying, oh, when I convert Anne, and the person Anne, the user Anne, to JSON and convert back, it should be Anne again. Oh, when I convert John to JSON and then back again, it should be John. So this is what we were doing before QuickCheck. And then QuickCheck comes along, and we no longer have to do that. We can just state it more or less once and for all elements of that type. And now with this, I can state for all, then there's this, in the sense of for all types in the API. Right? So there's an extra jump in expressivity that we're getting here. This is similar. It checks that, so it stores the serialized version of your, these are from the package servant async specs that Zonke Han and James Haver wrote. So this one checks that, that as new version, whenever you run it, it has golden tests. That is to say, it stores previous runs of the tests. And in this case, what it stores is previously serialized representations of your values that it picked randomly, and it checks that those are still valid, right? So in a sense, it's checking backwards compatibility. So you can continue developing without worrying about backwards compatibility. Now this is from my own package, Servant QuickCheck, a little bit longer the type, but it does what its name says. It checks that two servers are equal. There are some caveats, of course, but the essential idea is you give it an API type, and two base URLs. And it generates requests that are sensible according to that API type, and it checks that the responses are the same. Now, there's an args here so that you can run, you can change the number of tests that it runs, and importantly, there's a response equality predicate here, which allows you to tweak what equal means. Because often servers return, for instance, the date. And so if one server returns a date that's a second later than the other, you should still consider that equal. So you probably want to ignore the header date. And maybe, depending on what JSON library you're using, it might be two different languages. One of them serializes the JSON with an extra white space. But it's the same JSON in theory. Like this, morally, it's the same JSON. So you can change what it means to be equal. Well, yeah. Yeah. So when you're facing the sort of daunting task of a vast rewrite or converting, upgrading some core library, or rewriting from one language to another, from one web framework to another, those things are a nightmare. You're never sure that you're actually doing the thing right. And previously, you could have said, OK, I'm just going to generate arbitrary requests and see that the responses are the same. But without a description of the API, when you try to generate arbitrary requests, most of your requests are going to end up in the gutter, right? The URL is going to be non-existent, and you'll get a 404. Or the body that you're sending makes no sense, and you'll get a 400. Or you're missing some header that's expected, and still get a 400. So without a description of your API, it's a little bit like trying to generate. It's a little bit like trying to generate QuickCheck instances. Using QuickCheck by having an arbitrary byte string and trying to convert that into your type, right? You don't want to do that because there are a lot of byte strings that you might generate that aren't proper values for your type. And so this allows you to sort of focus on the sensible part of your API. Now,
you could define your API as a value.
Yes.
Just use the value to do this testing.
Yes.
So does the type, specifying the type add anything?
Does it add anything? No. It doesn't add anything in this package, but it so happens that it does for a lot of the other interpretations, so servant client and servant server. And so the assumption I'm going with is that you already have, or you don't want to do this at the value level, given that there are all these other things, all these other goodies that you could get if you just use the already existing servant DSL. Yeah, so you could in fact come up and.
Just trying to get at the exact point that the type is moving things to the type level, like really gives you power.
Okay, so the power comes from in the case of, so as I said, that you can generate client functions in Haskell for an API. Now the type of that client function changes based on the API, right? So if you have 2 endpoints, then you get 2 functions back. And if the one of the endpoints responds with user, then one of the functions responds with user. Whereas if it responded with something else, then your client function would respond with something else. And you need, and since in Haskell we don't have full dependent types, the type of your client function can't depend on the value of your DSL, of your API. So it has to depend on the type of the API. So we have to lift, in a sense, because we don't have the dependent types, we can't go up 2 types. So instead we lift the DSL itself to the types. And that's very important for servant client and for servant server, where the handler also changes this type. But for this package, it's not entirely relevant. But also the DSL is not, I at least don't find it particularly unappealing, so unappealing that I would try to create a new one just to be at the value level. So the other aspect of this is domain-specific knowledge. So have it as an example. Do people know the Qualsys SSL server test? Yeah. In case you don't, I'm gonna. Oh. I don't know if I know how to do this in. So what happens here is I write. So I write a website. So for instance, hackage.org. Sorry, Haskell.org. And it will run some tests. Let me see if I can. Make this smaller. It'll run some tests. And those tests are going to check for a bunch of well-known vulnerabilities in my SSL implementation. And I don't know anything about how to properly implement HTTPS. I really don't. Like, I maybe read 3 or 4 blog posts. There are tons and tons of vulnerabilities. There are tons of things that you could do wrong. And they're changing all the time. What this does is, in a sense, it keeps all of that information that would take me forever to become acquainted with, and I would immediately be out of date. It takes all of that information and puts it in a test, right? So now the test is actually. So funnily, when I was preparing for this presentation, I ran this, and we got Haskell.org got an F. So actually, preparing for this presentation, and then I told the infrastructure team, and they very quickly fixed it. But this is useful. What I mean by that, the reason why I brought this up is because this is useful. These are actually useful tests that people don't know about. The people running the infrastructure are probably much more qualified than I am with these things. But even for them, this is not something that immediately comes to mind, right? So I don't know why it still tells me to wait. Let me see. What? Oh, yeah. Okay, but anyhow, I don't care. So it tells me why it failed, like what's wrong, right? So it supports older protocols. So TLS 1.1 presumably is what they mean. I didn't know that it did that. It probably taken me a second to figure out how it does, like how to figure out how to know whether it still supports TLS 1.1. But it just told me, and then it gave me a link saying, more info, go over here, and I'll tell you how to fix this. Super useful, saves me a lot of time. And the reason why it does that is because it can encode domain-specific knowledge. So let's return. This is what I want tests to be like as well. And in Servant Quick Check, in addition to server is equal, there's another function that's called server satisfies. And again, it has that proxy API argument, the base URL telling me where the server is running, the arguments telling me how many tests run and other things, and then it has predicates, things that I can assert about my server. And these are quite easy to write, but there are a bunch, and expectation is like spec. It's like a HSpec specific thing that's very nearly a test already. But then there are these predicates, and if you go to the what a nightmare. Let's try to make sense of this. Okay, so this is a little bit small, but we have a bunch of predicates. So not 500, for instance. This is a predicate that states that none of the responses are ever 500. Usually a 500 happens because you have an undefined or a loop or something, or an exception in your code. This is basically running through the entire application and saying there are no exceptions that I'm throwing and not catching. Not longer than. I can check. I wouldn't say that this is like a production-ready benchmarking, but I can benchmark all of the endpoints in my API and say none of them should take more than 50 milliseconds to respond. Only JSON objects. I mentioned this before. Not allowed contains allow header. Probably most people don't know what this means. That's kind of the point. You don't have to. You just put it in there, and then if it fails, you go to the documentation for Servant Quick Check, and it has references that tell you, hopefully has a description that tells you why you might want this and when, and then more information in case you want to figure out more about it. And so there are several of these already. There are many more. So I think Arjen mentioned as an example that get is idempotent. I hadn't thought of that, but it would take very few lines to express this. And gets have cache control header. Lots of things that, again, are just a cognitive burden on someone who's writing web applications, but make things significantly better, make your API significantly better. So the idea is that you can just put all of these in a test. I state best practice, for instance. You can just pick all the ones that are best practice, put them in a test, and then if your application fails to, if they fail, then you figure out what they are. And so you've learned, this is the image of test that I want to have, not just of me being some divine creature, but also the test being a teacher that teaches you when you make a mistake. It doesn't try to overburden you with information, but it's there, I don't know, like a piano teacher who, like, when you're pressing the keys too hard, then tells you why it is that, exactly what it is that you're doing wrong. Someone much more wiser than you. Someone who has this sort of more experience in this area. So you can just combine a bunch of these tests, and then it'll generate 10,000, 20,000, however many requests that are sensible, and try to run all of them. And just quickly, here's what it looks like. So let's. So not 500. This is what it looks like when response status response not equals to 500 fail. Oh, I throw. There's a reason for throwing. I don't even remember what it is, but there's a reason for throwing exceptions rather than having an either. But this is it. There's one line of code, and it's and I've created a new predicate that everyone can use. That's, I think, quite useful. So there are a few. I sort of wanted to give a whirlwind tour of the testing world, the testing world that Servant enables. This doesn't require, as I mentioned, that your web application use Servant, at least for some of them. Like servers equal, for instance, has 2 base URLs, and it could be a Django and a Rails web framework. But having that description, that DSL, that you can describe your API with, gives you access to a wide range of new testing tools. And this is not the entirety of them. I'd like to also shout out to Servant Mock, which for integration tests is really useful. I won't have time to describe what it does, but it's interesting to look at. Also, you can prove, some caveats with the prove, but you can sort of prove certain properties of the API, not test, but prove. And you can ask me about that afterwards. And benchmarks as well. More extensive benchmarks are another interesting idea, that automatically generate benchmarks and try to figure out what's the slowest or the unacceptably slow in your application. But this I'll just point out to. For now, thank you. These are the packages that I mentioned. Yeah.
So this is very nice. So I really like the thing about, let's check that all of these things are not 500, that they round trip, et cetera, et cetera. Are you able to do more precise control when you need to?
Yeah.
And like for example, the performance thing, like all of the customer-facing things should return in less than 50 milliseconds or whatever. Yeah. But the admin API, I know it's slower. It's okay for it to be slower. So you somehow need to be able to have slightly more precise control than just everything. Can you do that when you need to? Yeah. So that's a very good question. And there are 2 ways in which you can do that. So the first one is as I said, I sort of wanted to say as an analogy that the API type that you pass in as an argument is a little bit like a paper with a hole in it, and you're looking through it, right? You only see what your API type describes. And so if you change your type and it's not the entire description of your API, but only a sub-API that does not include the admin sub-API, then only that will be tested. So that's one way in which you can do it. The other is also in the predicate itself, right? So the predicate gets access to both the request and the response. So there you can say, well, if the request is going to the admin API, then don't fail. Don't do any tests at all, right? So there are 2 layers where you can do that.
So this relates to a question I asked on the mailing list, which is being not doing things correctly when dealing with the web, and in particular, so you have an API and you're supposed to check for content types, and this is what Servant does, kind of if you're just using it out of the box. Yeah. But I have this situation where a bunch of clients have written integrations which are bad, and they don't obey the rules. Yeah. And I'm rewriting my app, and I want to make sure that the new app has the same behavior, including not obeying the rules. Yeah. Because I don't want their integrations to blame, because otherwise 20 customers will come and shout at me. Yeah, yeah. So can I do this?
Yeah, you can. So server is equal is sort of that function that I showed earlier. Specifically, if you're talking about rewriting an API and rewriting something, including all the warts, server is equal is unaware of any best practices. It'll just say, okay, you're not doing exactly what you were supposed to be doing. Modulo that notion of equality that I mentioned. So there it doesn't matter. Like there's no intrinsic. You will, as you did already, you will often find situations where it's kind of hard to do the wrong thing in Servant.
I think we're proud of that. I'm not sure. But with respect to this itself, if there's a test and server satisfies that you don't want to run because you actually want to be wrong, like you want to mimic some other behavior, then just don't run it, right? Anyone else?
I didn't have a specific look at Swagger, but is it possible to encode something on the value level into like the 2JSON schema information? For example, if I have a user and a username and a user age, I obviously want to have that user age is non-negative and less than, say, 100 or 150.
Yeah.
Is it possible to encode that in the toSchema definition? So I have the arbitrary, the generated arbitrary values in there? Or is the arbitrary separate?
They're independent, yeah. So the arbitrary will continue. The toSchema, what you say in your toSchema will not change. Oh, actually, well, Nikolai just walked into the room. So I don't think that it would filter out in the test. I don't think it would filter out the values that are generated so that they already have that property.
Okay.
They would check that they have the property once they're JSON, right?
So there's no you need to program that the
into your arbitrary instance. Yeah.
The arbitrary value is dependent on the toSchema version or vice versa.
I don't know how you would do that, but you have to in a sense you have to actually sort of make sure that they match, right? Or,
okay.
Which I don't know if that was meant as a joke, but. Cool. Anyone else? Okay. Thank you then.